Today we're going to talk about rational and irrational numbers. So get your interactive notebooks out. You're going to put your title page of rational and irrational numbers, and then you're going to flip to that page to take some notes on the difference between a rational and an irrational number. So first we're going to start, we're going to make a Frere model so you can kind of sketch this in your notebook to help you. We're going to talk about what a rational number is first. A rational number, by definition, is a number that can be written as a fraction. So any number that can be written as a fraction is going to be a rational number. So some facts and characteristics about numbers that can be written as a fraction are: this could be a whole number. Because any whole number can be written as a fraction by putting it over 1. It can be a positive or a negative whole number. It can be obviously a fraction. It can be a decimal that stops. So a decimal that stops would be like 1.4 or 1.25 or 1.6. It also can be a decimal that repeats in the same order. So decimals that repeat in the same order would be like 4.2 repeating, 6.7 repeating, 6.232323, etc. The other type of number that can be a rational number is any perfect square. So the square root of any perfect square. So perfect squares are numbers. When you multiply them by itself, it gives you that number. So perfect squares are 1, 4, 9, 16, 25, 36, 49, etc. So I will put a post on Google Classroom with all the perfect squares on it. You can also use a calculator to check if something's a perfect square. So when you take the square root of it, it has to give you a whole number. So examples of these, we said it can be a positive or negative whole number. So -2 is a rational number. 4 is a rational number. You can have any type of fraction. So 1/2, -3/5 are fractions. A decimal that stops, 1.25, -3.6. A decimal that repeats in the same order. So to notice that it repeats in the same order, that's when you have the line above it, or it'll just have the same number over and over again. Perfect squares, the square root of 81, because the square root of 81 is 9. The square root of 36 is 6, because 6 times 6 is 36. So all of those are examples of rational numbers. Okay, a number is either rational or irrational. It can't be both of them. So an example, the non-examples are going to be irrational numbers. Irrational numbers are numbers that can't be written as a fraction. So anything with pi is irrational. So we could have pi, we could have 4 pi. It is any square root that is not a perfect square. So we said perfect squares are like 1, 4, 9, 16, etc. Because when you take the square root of that, you get a whole number. So the square root of 5 isn't a perfect square. The square root of 15 is not a perfect square. So those are irrational numbers. Also, a decimal that repeats in no order is going to be a non-example. So 4.1325, etc. It's not repeating in any order, is not a rational number. So all these numbers, these non-examples, are going to be irrational numbers. So the next word we're going to talk about is going to be irrational. So we're going to look at another Frere model to help us talk about irrational numbers. So an irrational number is a number that cannot be written as a fraction. So examples of numbers that are irrational are the square root of any number, that is not a perfect square. So the square root of 7 is not a perfect square. The square root of 10, the square root of 12. These are all examples of numbers that are irrational, because when you take the square root of them, you get a decimal that repeats in no order. Another characteristic is a decimal that repeats in no order. So if you have a decimal and it has no repeating order, then it is irrational. And the last one is anything with pi. Okay, that's the famous irrational number. So anything that you have with pi is going to be irrational. So examples of irrational numbers are the non-examples of rational numbers. So a square root of anything that's not a perfect square, the square root of 7, the square root of 12. When you take the square root of those, you don't get a whole number. So that's why it's an irrational number, because it's a decimal that repeats in no order. 4.32976, etc. That's irrational. It's a decimal that repeats in no order. And then anything with pi. So we could have 5 pi, and that would be irrational. Non-examples of irrational numbers are rational numbers, because a number is either rational or irrational. So non-examples would be a whole number, a fraction, a decimal that stops, a perfect square. All of those are examples of rational numbers, so they're not irrational. So today, the last thing we're going to do is we're going to classify numbers as rational or irrational. So we're going to look at these examples and decide if it's rational or irrational. So make sure you figure out the question, rational or irrational. So we're going to state whether each of these are rational or irrational. So the first one we're going to look at is 2 pi. Well, anything with pi in it is going to be irrational, because pi is the famous irrational number. So the first one is going to be irrational. Part B, we have a decimal, 2.3. This decimal stops. So if you have a decimal that stops, it's going to be a rational number. The square root of 36. So this is when we're talking about, is 36 a perfect square? If you're not sure, you can use the calculator that I posted on Google Classroom, or you can look at the lists that I've posted. So if I need to figure out if the square root of 36 is a perfect square or not, I'm going to hit the square root button and 36. If it comes out to be a whole number, then it's rational, which it equals 6. So it's a whole number. So that means my number is rational. If I take the square root and I get a decimal that repeats, then it's irrational. So for example, the next one is the square root of 2. So if I take the square root of 2, square root of 2, and hit enter, it gives me a decimal that repeats in no order. So this isn't a perfect square. It is a irrational number, because when you take the square root of it, it's a repeating decimal, no order. Part E, I've got 2.3654782, and so on. Okay, this is a decimal that repeats, but it doesn't repeat in any order. So if it's a decimal that repeats in no order, it is irrational. Then the letter F, we have 1/4. Well, 1/4 is a fraction. And if your number is a fraction, it can be written as a fraction, it is a rational number. And then finally, we have 0.52. 0.52 is a decimal. The decimal stops. So since it's a decimal that stops, it's going to be rational. To show if it was a decimal that repeated, it would have dots after it. And then H is 18. 18 is a whole number. A whole number can be written as a fraction by putting it over 1. So this is going to be a rational number.